My name's Merc Martinelli, and I've just met everybody over pizza, but thank you all for coming tonight. I really appreciate it. And what we're going to talk about tonight is operations management specifically for startups. So this is the title slide. And how many people here have seen the Coyote and the Roadrunner cartoons? Okay, a few, right? So every time the Coyote wants to capture the Roadrunner, he orders something from Acme Corporation. So I decided that we're going to work for Acme Corporation tonight, and we're going to talk about how to profit making widgets. And this was actually, I found it on the web. It's all the products that the Coyote bought over time, and none of them work too well. So we're going to try to make products that actually work well. Okay. So it's a little bit about myself. I've been in the Valley for a number of years here. I've got experience at startups and also Fortune 500 companies. Most of my expertise is in operations. Some of the highlights include program management, supply chain management, and key customer support. As of last week, I have a new job working for Oakbio. I'm the VP of Strategy and Partnerships there, and Oakbio is a company that captures carbon dioxide from smokestacks and then processes it to make either bioplastic or other usable products. And just the trivia, back in the day I flew KC-135s in the Air Force, which is the Boeing 707 set up to refuel other airplanes. So some of the questions that we want to answer about operations, I broke it down into some of the high-level metrics. So cost, quality, schedule, and also performance and service. So under cost, you know, what is the relationship between prototype cost and your Rev 1 product? Under quality, what should be the target for prototype quality and Rev 1 product quality? For performance, is there a role in operations in product performance, and if so, what are the priorities? And then schedule, you know, how much should the development schedule slip, parentheses, if at all, to not affect market uptake? And then finally, service, what should be the target for Rev 1 service response? So, cost. So at a high level, here's some important things to consider when you're looking at cost. So the first is bill of materials. And you'll hear people use the phrase BOM in the industry. So it's not only how many parts are in your product, so obviously lower is better, but also are those parts primarily available on the open market, or are they custom parts? And the reason we want to look at that is because custom parts then require extra effort on the part of the subcontractor, and sometimes if the part is complicated enough, it ties you into a specific subcontractor. So that's something to consider. Next is MOQ, or minimum order quantities. When you're doing prototype development on the engineering side, you might be ordering, you know, 5 of this and 10 of that, fairly small numbers. But once you get into manufacturing, you're going to have larger orders. And so the subcontractor will issue a quote, and it's going to be broken out in minimum order quantities. So 500, 1,000, 5,000, 100,000, right? Really, really big numbers. And the price goes down every time you go up that scale. So there's something to be said about ordering a little bit on the higher end, as long as it doesn't cost you too much in inventory holding costs. So that's something also to consider. Next is the PO, or purchase order. And what happens when you place that purchase order is the factory is going to expect you to pay at least a third and maybe half the total cost. So say it's a $100,000 order, you're going to have to pay $50,000, and then later on, once they've finished making everything, you pay the second $50,000, subject to terms and conditions. So a lot of businesses have maybe 45-day terms or 60-day terms, but still you're going to pay for it pretty early up front. And then you've got to sell that product out to the marketplace to recover the money that you just spent. So that's another important consideration to consider at the time. And then finally, tooling. If you have a custom part, then you're going to need a custom mold or other fixture to make that particular part. And if it's really complicated, it will tie you into that particular subcontractor. So that kind of relates, back to up here. If it's a custom fit, it's probably also a custom tool, and so that ties you in. So on the one hand, if you have a product that you can make with all generic parts at high quantity, then you can get the price down pretty low. But every time you customize something, that moves the ribbon the other way, so to speak. Quality. So this is some high-level bullets looking at prototype quality versus production quality. So prototypes, you want to optimize for quick turns. You want to optimize for functional verification, and you want to work to lower design errors, basically. Whereas production, you're optimizing for volume, you're optimizing component costs, and you want to reduce manufacturing costs. So they're different things. So frequently, the price of the prototype could be 4 to 10x more expensive than the actual production product. And so that's something to consider. When I was at a solar company, this gentleman right here, one of the first projects I had was to work on reducing the cost of the solar panel. So we had just come out of engineering, we had prototype quantities, and the cost of the panel was about $200 a piece. And at that time, we wanted to get it down to $100. So we had a brainstorming session, and we got all the right, managers and directors in the room, and we went all day thinking about how can we reduce the price of this, that, and the other thing. Wrote them all down on a giant spreadsheet, gave everybody a project on that spreadsheet. I had multiple projects. And then as we looked at how to implement it, we ended up having 3 team meetings because our process was basically there was a front-end process to make the solar cell on the absorber side, and then there was a back-end process to add the wiring connections for the solar cell, and then there was an encapsulation process where we sent the solar cells over to Germany, where we had our panel factory, and they put the glass on it and laminated it, and so on and so forth. And as it turned out, for that project, most of the cost savings were available on the German side of the equation, because they were buying big sheets of glass, basically 2 meters long by 1 meter wide, and they were buying them at a high technology supplier in Germany, which was great in terms of if you needed an extra piece of glass, you could drive over to the factory. But in terms of costs, it was very expensive. So we actually transferred that business to China. And even with the logistics involved, it was absolutely the right thing to do from a cost perspective. So it's something to consider when you're looking at cost and quality. You need to understand, what the trade-offs are. Now, performance, and by the way, you'll notice on each of these slides at the bottom there's web addresses, and those are example articles where I got some of this information, in addition just to my own personal experience. So I think we're going to mount these slides up on the web somewhere. Yeah, so you'll be able to look at them and oh, we got a little problem on the third bullet there, but that's interesting. Let me try something for a second. No, it's just going to be like that. But anyway, this, yeah, odd. Yeah, you can write that. Read that. Okay. So anyway, this is talking about how software and hardware interface in a technology product, and fundamentally, developing software for the hardware product, you need to have a prototype of the hardware product that the engineers can work to, right? So that's what this is really saying. increasingly dependent on the underlying development target that represents the final device. Now, complex IP depends on software, which needs to be available during this integration process. And the SoC, which is System on a Chip, and I'm going to read it here. Architects need embedded software to explore trade-offs between power and performance. So, again, you need a fairly stable prototype to be able to do that development. I'm not quite sure why that's doing that. But anyway, the point about performance is if you have a prototype that is essentially very, very close to the final design, then it makes it easier for your software team to develop the software for that particular piece of hardware. All right, schedule. So I want to start actually with the bottom bullet. And the question is, how does a project get to be a year late? And the answer is 1 day at a time. So this is talking about little slips here and there can have a very big impact on the schedule. So think about, for the schedule, understand and apply the techniques of CPA, which is critical path analysis. So if you, at the beginning of the project, draw out a PERT chart, right? And there's several different software packages that allow you to do that. There's going to be a path through all those tasks which are interconnected, and that's called the critical path. And so if there's a delay on the critical path, it'll stretch the whole development timeline. And so what you need to be able to do is, number one, get everybody on the program team to agree what the schedule tasks are, how they're related, and then everybody to agree on what the critical path is and why. And then, at your weekly team meetings, which is typical, you can review progress against that schedule, and if there's issues, you can have a coherent discussion in the group about how to move forward. Which is kind of this first bullet here. Make sure you have a schedule that everybody agrees to. Now, culture, blaming culture. So there's a lot of companies out there, and they all have different cultures. As a matter of fact, a long time ago, I was a service manager for a semiconductor equipment company. And so I'd go out up and down the West Coast and visit all the manufacturers like Intel and AMD, people like that. And I would find that each company had its own unique culture. And usually it was reflective of the CEO. If there's a small startup, they've got a new technology, they get some funding, they start to hire people, and they tend to hire people somewhat like themselves. Now, I don't mean in terms of the way they look, I mean in terms of the way they think, right? So Intel had one type of culture, AMD had another type of culture, et cetera. And there was probably 10 to 12 customers that I was dealing with, and each one had a very unique culture. And sometimes the development culture is to blame other people, right? So when something goes wrong, it's easy to say, well, the real issue is, Fred or Susie or Joe or whoever it may be. And so that's something that as a project manager, you have to kind of work your way through. If there's a culture of not accepting responsibility, then that's an issue that has to be dealt with. Next is to establish the root cause. And there's a number of program management techniques out there that allow you to do that. For example, you can do a fishbone diagram. There's others out there. But you want an understanding on the team of what the root cause is. And it sounds simple, a short bullet, right? Establish the root cause. But you have people with different views on the problem and the project, and there may be differing ideas. And so then you need to develop tests to sort of sort out what is the root cause of the particular delay we're talking about. And then change control. So the idea here is that when you start a program, you define it, you built your schedule, you know your performance specs, you know the cost targets you're looking at, et cetera, et cetera. And then there's a point where everybody agrees, okay, this is the plan moving forward. And in some companies I've been in the past, the team would present the plan to executive management. And the executive team would go, okay, we bless you, go off and develop the product. But that means then that once that blessing happens, anything that changes after that needs to go through some sort of a change control process. Right? So if you're in production, change control is handled by putting letters and numbers after the part number, revision control, like A1, A2, B0, B1, B2, etc. And the difference between an A and a B, it's a higher level of difference than between a A1 and an A2, right? So change control is important even as you're doing the development. And so again, at the weekly meeting, that's a great topic of discussion is, okay, were there any changes to the project this week? And if so, does everybody agree that that was the right path for us? Then onward to service. Okay, so things about service. I got this from an article, again, in addition to my personal experience, about prototyping. And so it was talking about how doing good prototypes can help teams deliver better service. And so there were kind of 3 bullets out of that article that I thought were worth mentioning. Number 1 is build, observe, and learn quickly, right? So when you find problems, you need to understand it really quickly because now that your product's out in the field, you don't have a lot of delay time. And generally, what I've done in the past is then there's a second meeting before the product is released generally. And it's the same group of executives and it's the same project team. And you report back and you say, okay, we've done this development. Here's where we are on cost, quality, reliability, etc. And we think we're ready to go. Do you all agree? One by one, they go around and sign the document. And literally, we had people sign their names because then there's no, I didn't really say that or whatever, right? You have a written record. And so both of those meetings, the one at the beginning to define the product and put it into development, and then the one at the end to take it out of development and release it to the market, those are very critical. And so we used to call the process literally the funnel Tootsie Roll plunger, because when you drew it on a slide, that's what it looks like. You've got this ideation funnel, you slim down the spec, you agree on it, then you run through the development steps, and then at the end, you have another meeting to say, okay, are we ready to go to market? And then you launch. And you launch, depending on the industry, very, very quickly, and it's a bell curve, right? So you're ramping up, you've got big production, and then you ramp down production because the next product's coming along. Now, again, it can be very different depending what the industry is. I'm speaking more with a high-tech background, but there are other industries where things don't change quite as fast. I think there's something to be said that the startup COO might be the first program manager, because that person owns the factory, and they're going to own the release, and they're on the C-suite. So you might start like that, or you might bring in a contractor, or you might bring in someone from the subcontractor. Typically, they have some program managers that they can apply to specific customers. So there's a number of ways around it. But you're absolutely right. For a startup that's on a lean budget, yeah, they have to be creative to get around that. Well, I think it's going to depend on the industry and the product. I think it would be good to have at least one player from the mothership, so to speak, be the program manager for that project. Although, there's different ways to attack that, right? So, Apple, even though I personally haven't worked there, that's part of what they do is they have program managers for each of their projects who work with the suppliers frequently in Asia, right? And so Apple has a control and understanding of what's going on with their product development, even though it's not their employees who are doing most of the work. So that's one approach. There's others, but that's one that I'm familiar with. It's something that I thought about as I was developing these slides. So the supply chain is basically selected in many ways by the program management group, right? So you need the engineers working with the subcontractors to put the specifications together for the parts. So it's a team effort. Now, once it's actually in production, then it's the job of the supply chain team to manage those subcontractors. But during development, it's more of a cross-functional approach. And yeah, so when I went through this, partly because of my own background, but partly because of the way I've seen these projects work, in the end, the company wants a certain cost, a certain performance, a certain market uptake. There are specific metrics that they want, and the team works on that together, including selecting the supply chain. To be continued, exactly. But thank you.